Okay, welcome back. We are on the 13th installment of our New York State Chemistry Review Overview. We are trying to cover the New York State curriculum unit by unit, and we are trying to, go for the broad strokes, the most important things for each particular topic. It won't be fully in depth. It won't go into the nitty-gritty details, but it will give you the basis that you can then go and review that unit for. So organic is a very straightforward kind of unit. There are rules, but if you follow the rules, everything is kind of simple. This unit all stems from the fact that an organic compound will contain the element of carbon. All right, the element of carbon has to be in an organic molecule to make it organic. Okay, so carbon will and has bonded to itself. It can form chains, it can form rings. The homologous series is on your reference table. You can find it on table Q. And what table Q is really going to show you is the difference between alkenes, alkynes, and alkanes. How they're named, it gives you an example, it shows you a picture, it gives a name, it gives you all the information you really need. The one thing, though, that it does not supply you with is the term saturated and the term unsaturated hydrocarbons. A saturated hydrocarbon is only classified as an alkane. And the reason, or what makes it an alkane, is the same reason why we call it saturated, is it's something that only has single bonds between the carbons. So every bond between carbons has to look like that. That's what makes it saturated. An unsaturated hydrocarbon is exactly what you would think it is. It doesn't have what we just talked about. It doesn't have only single bonds. Yes, it will have some single bonds, right? But it can have doubles or triples. And so, slide this up a little. Alkenes with an E depicted on table Q, and alkynes with a Y depicted on your reference table will have the unsaturated. An alkene will have a carbon-carbon double bond. An alkyne will have a carbon-carbon triple bond. Okay, these two things are considered unsaturated. Some other terms that you would have talked about during this unit that we definitely did is isomers. It's getting even slower as the day goes on. Isomers. And isomers are organic molecules that have the same molecular formula, but they have different structural formulas. And because they have different structural formulas, they're going to have different properties. I'll draw you an example of a very simple isomer here on the right side. Lots of people might think that a compound like this, here we go, almost there. Lots of people would think that this picture of ethanol and this picture of ethanol are different structures. Okay, but the fact is they're not different structures. Those two images that I drew are the exact same thing. Now, I know that for a couple of reasons. One, I could rotate the picture that is drawn, and it would look exactly like that. Either one. But more importantly, if two molecules have the same name, this one is called ethanol, and this one is called ethanol, they're not isomers. They can't be. Yes, they have the same molecular formula. They are drawn differently, but their structure is not different. And as evident by the name. What I can do is take this same C2, H6, and O, and I can redraw it differently. I could draw it as an ether. So there are my two C's and my one O. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5, 6. And I can redraw it that way. Now, those are clearly two different pictures. They're put together differently. C is bonded to O, and then it's bonded to C, versus C is bonded to C and bonded to O. Okay, these two things are called isomers of one another. They have different structures. They have different properties. They have the same molecular formula. 3 organic reactions that are worth talking about. There are more than 3, but the 3 that are definitely the most common and worthy of talking about. One of them is fermentation. There we go. Oh, this is painful. Painfully slow to write this. Fermentation. You can always determine a organic reaction is fermentation because the products will always result in an alcohol and carbon dioxide. If those are your products, the process is called fermentation. Process of making an alcohol. Fermentation. Esterification, again, it's another easy one. All you have to do is look at the product. Esterification makes an ester. Now, there's a much more technical way to go about this. You know, at a higher level of chemistry, you would say something like an aldehyde and an organic acid come together and to make an ester. And that's true. And maybe, you know, I don't teach it that way, but some people do. I know that the Regents really only cares that if you can identify something as esterification because the product is an ester. All right, so just keep that in mind. Just look at the products. If it's an alcohol, it's fermentation. If it's an ester, it's esterification. If you take a bunch of small things and join them into a larger one, that is called polymerization. Oh my goodness gracious. You know, I really thought today was going to be a nice day to do it. We don't have students, so I assumed the network would be nice and fast. It's not. Polymerization. Taking a bunch of small things and joining them up into a very, very large one. Okay? Those are 3 things that you need to know. And lastly, the process, the rules of naming an organic compound. These 3 things are the same. Every time you have to follow. The first thing you need to do is identify what we call the main chain. The main chain is the one that is the longest or the one that has the double or the triple bond in it. So the main chain is what you look for. It's called the backbone. We find that. And then we name it. I'll do these 2 examples down here in the bottom in a moment for you. Then we identify branches. right? Branches, whether it's a methyl group or an ethyl group, we find the branches that are not part of the main chain. And the numbering process has to be from, or what would result in, the lowest number on the branch. So you can count from the left side of the molecule, you can count from the right side of the molecule. Either way you count it, you have to look for the way that gives you the lowest number possible. The third rule is we have to name any branch as a methyl or an ethyl or a propyl, and or we need to name any of our functional groups See, if I start to write a little bit faster, that's what happens. Okay, we name any of our functional group with the corresponding number that we just did in number 2. Right? Whatever way we're numbering, that's the way we have to go. And then you name the main chain. Okay, so if we look at these two down here, we can see that the longest stretch of carbon is 3 and 3. So both of these are going to have a prop backbone. Then the plan, if that was all it was, there were no O's there, both of those would be called propane, assuming they were filled with H's. Then we look for things that are not part of the main chain, that are not hydrogen. And in this case, we have these two situations. Table R on our reference table is super helpful. Most of the time, I kind of give table R to my students or you, and I have them figure out how table R works. They just kind of look at it and they look at pictures of molecules, and you can clearly see the resemblance of certain things. So for instance, if you were looking at this section of this molecule and comparing it to table R, you would see that that's an aldehyde. It's got a C, it's got an H, and it's got a double bonded O. If you were looking here, you would classify that as a ketone. It's a double bonded O right in the middle of a molecule. It's bonded to a C that's bonded to other C's. It's a ketone. So they're different. And in the way we're naming, prop is our backbone. These functional groups change the suffix of our name. So aldehydes, again, this is also on table R. Aldehydes end in anal. Ketones end in unknown. And so, with that said, the names of these two things would be propanal and propanone. Now, some of you might be arguing about propanone. Wouldn't this be called 2-propanone? Well, if you put 2-propanone, it wouldn't be wrong. But you don't need it for a 3-carbon chain. Because either way you count, it's always going to be the second carbon. Right? Look at it. Left to right, it's on the second carbon. Right to left, it's on the second carbon. So either way you cut it, these would be, you wouldn't have to write it as 2-propanone. Now back to what we said before. Same molecular formula, different structure. And if you were even concerned, maybe like, oh, I can't see the difference in the structures. Like, just say you were one of those people. If they have different names, they cannot be the same molecule. Okay, propanone and propanal are isomers of one another. C3H6O with different structures. So I hope this gave you a nice little quick background. Go practice it. Go work on it. Practice naming. Practice formula writing. Practice identifying table R functional groups, and keep working. You've been doing this all year. Make the most of it come your final exam. So Thank you so much for watching. Please like the video, subscribe to the channel, and we got one more video, and I might make some other videos for some other types of situations, but we got one more video to recap the year. So thanks a lot.